Okay, they want us to graph it. I just graphed it. Okay. When you're graphing, you want to think of scale. My oldest daughter, she's doing this right now. She's trying to figure out scale and how to change scale. All I can say is keep your scale linear. In other words, if you're going to go up by the same amount. Now, it doesn't have to be the same amount on the x and y. When I look at this, I ask her, what's your domain, what's your range? Right? What's your domain is your x. Right? So, 1 to 5. Okay, I can scale 1 to 5. 1, 2, 3, 4, 5. That's easy. What's your domain? What's your range? Your range is your y. Okay? Domain is x, range is y. So what's your range? 0.2, 0.4, 0.7, 0.8, 1.0. And I'm like, well, no, it doesn't sound easy, right? It actually is. If we did 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10, right? It's just like going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Except with points. Okay? Does that make sense? So we just changed it. We go up by the same amount, 0.1 every time. So we're going up linearly. Okay? And that keeps everything nice. So now I graph it. So do you notice how I graphed this? Really easy. I said, hey, 0.2, I wrote a 0.2. 0.4, I wrote a 0.4. 0.7, I wrote where 0.7 was. 0.8, I wrote where 0.8 was. I'm giving my mind a reference point, right? So now I just have to go, okay, 0.2 up 1. 0.4 up 2. 0.7 up 3. 0.8 up 4. 1.0 up 5. Does that make sense? So it was really easy for me to graph it. Does that make sense? A little bit? So, again, keeping my points, 0.1, 0.2, 0.3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but instead of a 10, it's 1.0. Okay? Okay, and then now they want to know what your rate of change is. So they want to know the slope. Now I could have done this the hard way. Well, you have to know the slope of each point between each point. So therefore, you have to know m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right? And then I got to take in this point, and I got to take in this point. I got to plug those into the equation and plug it out. Right? And that's how a lot of us old, typically white male math teachers teach. Right? Because we're just very straightforward, and here it is, and just going to hear our monotone voice, and this is how we're teaching. Right? So, you'll see a lot of math teachers are this way. Okay? That's cumbersome. Now, I could go into my way, a little bit more even flow, a little more like, hey, we're going to flip it and smack it. Yeah, we're going to flip and smack each one of these. That's still, Albie, tired, wake up. That's still a little boring, as you can see, right? Not only boring, a lot of extra work. You don't have to work that hard to find slope. Now, if they're giving you 2 points, flip it and smack it. Do your equation. That's what this is. This is flip and smack. You take each 2 points and you flip them and then you smack. But we don't really have to do that here. We just need to find the rate of change from here to here. So we need to, how much does it change from here, from 0.2 to 0.4? How much is the rate of change in your x? What's your change? What does it change from 0.2 to 0.4? So what's the difference?
But then it goes up one.
Yeah. But we're not worried about that going up one yet. Just worry about what's the change from 0.1 to 0.2, or 0.2 to 0.4. 0.2, right? You agree? 0.2? Okay. What's your change between 1 and 2? What's the change between 1 and 2?
1, right?
1. Yeah. Okay.
Those 1.2.
So, whoa. Slow your roll. Okay. So this is the change of y, right? So remember, slope is equal to the change of y over the change of x. So now I can just plug those in. The change of y is 1. The change of x, 0.2, right? And I can plug that in my calculator and find it out. What? Boo. Right? Or I can think about it for a second. What is 0.2? 2/10, right? Did I ever tell you the story about the guy who goes into the native kid goes into the psychiatrist, and he's like, man, doc, I've been having these weird dreams. I've been dreaming like I'm a wigwam, and then I'm dreaming like I'm a teepee. I'm dreaming I'm a wigwam, then I'm dreaming I'm a teepee. And he's like, man, you're too tense. Jeez, come on now. Get it? Too tense. Man, my jokes aren't working. All right, so 2/10. 2/10. 2/10. That's it. That's all it is, right? And so when I think about this, and I'm dividing by 2/10, 1 divided by 2/10, right? Then I'm really at, I flip it, right? When you divide by a fraction, you flip and multiply. 1 times 10 over 2. 5, right? So that's all that is. 1 divided, now you'll plug it in your calculator and you get 5. Boom. But we could have done that ourselves pretty easily, right? And the reason why I'm doing it like this, is thinking about it like this, is because every single one of these is going to be 1 over, isn't it? 1 over this, 1 over this, 1 over this. And if we think about it as 3/10 or 2/10 or 5/10 or whatever it ends up being, it's always going to be 1 over that. Then we just flip it. We're just finding the reciprocal. Okay? The reciprocal is 10 over 5. Or, sorry, 10 over 2, which is 5. So this one, your rate of change between these two is 5. 5 over 1. That's your rate of change. Now when we look at these two, okay, it's going to be a little bit different, right? Now we're going from 0.4 to 0.7. How many differences is that? 0.4 to 0.7.
6.
So 4 to 7?
Oh, no. It's like 5.
4 to 7?
7.
4 to 7?
Fuck, I don't know.
All right, let's look. From 4. From 4 to 7. 3. Okay, from 4 to 7, it's got 3 spots, right? So from 4 to 7, 0.3, right? And so it's 1 over 0.3. So 3/10, what's the reciprocal of 3/10? 10/3. Okay? All right, and then from these two, okay? Now what's the difference between 7 and 8? 7 and 8. 1, yeah, 0.1, right? So what's the 1/10? What's the inverse of 1/10? Inverse meaning I just flip it. What's 10 over 1? Yeah, 10. Simple, right? Now this is a little easier, maybe. Does that make sense? Once you see what they're doing, right? They're trying to make it hard. It's not hard. You know, don't let them trick you. That's what I'm trying to say. Now when we go from 8 to 10, from 8 to 10, how far did we go? 0.2, right? So 2/10 again, flip it, and you get 5. So your rates of change are 5 over 1, or 10 over 2, 10 over 3, 10 over 1, 10 over 2. And that's your rate of change. Does that make sense? For the most part? Okay? And then that way you don't have to worry about the other stuff. As far as like graphing 1 to 10 or 0 to 1. Okay?